China's first lunar sampling return mission, Change 5, collected 1731 g of lunar soil in the early morning hours of December 17, 2020. After 44 years, humans have successfully reintroduced lunar samples. What scientific value does the lunar soil we attempted to recover have? Lunar soil is a worn substance that covers the moon's surface. The thickness varies a lot from one place to the next. The lunar soil layer in the lunar mare area is 4 to 5 meters deep, whereas the highland area can be 10-20 meters thick, owing to meteorite impact, solar wind bombardment, and the fragmentation of lunar rock caused by thermal expansion and cold shrinkage. Because the moon lacks air shielding, it is often bombarded by meteorites and micrometeorites. Hence, the impact of meteorites and micrometeorites dominates during lunar soil formation. This meteorite's long-term activity is also responsible for the complex and diversified composition of lunar soil, which has multi-source mixing properties. We know the particular mechanism of this process because of data returned by the Chinese Yudu-2 lunar rover. The asteroid smashed the rocks on the lunar surface and compacted the lunar soil, then cemented it together by partial melting to create the wall and bottom of the tiny crater in the lunar soil layer. The wall and bottom are blast-glued lunar soil masses that were struck and expelled by another asteroid, dropped to their current location, and eventually broke up into splashes. The moon's soil continues to change and mature as a result of repetitive impact, thinning, and regirding into rocks. Second, the temperature difference on the moon between day and night is enormous. Furthermore, the thermal expansion and cold contraction on the lunar rock's surface are greater than those in the core. The significance of the solar wind in the production of lunar soil is likewise inextricably linked. Because there is no magnetic field or atmospheric protection, high-speed solar wind particles drive straight in for a long time, ion implantation, structural amorphization, and material sputtering on the surface of broken lunar mineral particles, and then deposit on the surface of fine particles, changing the structure and composition of lunar soil particles. The intricate production process of lunar soil has resulted in its high scientific worth. The study discovered that the lunar shell is thin and has a high concentration of kryptonite, which is frequently accompanied by enrichment of radioactive elements, such as uranium and thorium. Will radioactive elements heat up the lunar mare, resulting in more magma underneath and a thinner lunar crust? This radioactive elements riddle will be solved by studying lunar soil. Lunar soil can also be utilized as an artificial photosynthesis catalyst. The Chinese research team has evaluated Change 5's lunar soil several times and offered practical steps. Carbon dioxide is directly extracted from the air that humans breathe by using the unusually low temperature of the moon at night. The Change 5 lunar soil then transforms respiratory waste gases and water resources mined on the lunar surface into oxygen, hydrogen, methane, and methanol by acting as an electric catalyst for water breakdown, and a photothermal catalyst for carbon dioxide hydrogenation. This study proposes a viable method for the construction of an in-situ resource utilization system on the moon that can adapt to the severe climate and requires just solar energy, water, and lunar soil. Humans may attain a zero-energy consumption, interplanetary life support system based on this technique, which actually enables lunar exploration, study, and travel. Furthermore, by examining lunar soil, we can learn about late-moon volcanic activity, as well as the solar system's impact history and life development. Of course, these moon riddles are not simply solved. The road to investigating the unknown is guaranteed to be full of twists and turns, and we can only get closer to the solution by exploring again and again. In the distant, there is a sea of stars, and humanity's exploration of space is limitless.